So we have understood the mirror formula, which contains some variables like object distance, image distance, focal length. So while using that formula in numericals, we have to use some convention for these variables, that which quantity has to be negative and which quantity has to be positive. So now we are going to discuss about that convention only. Okay, so the basic of this convention is that all the distances which we are measuring from the pole, if the distances are in a direction which is the direction of light rays from the object towards the mirror, that direction should be the positive direction. So I mean to say, suppose this is the mirror, this is some mirror, it may be spherical or plane mirror, and suppose this is the object. So when light rays will be moving from the object towards the mirror, so that means the light rays are going towards right. So if this is the pole of mirror, so that means the direction towards right of the pole, that direction will be the positive one. And suppose if object it is on right side, so light rays will be moving towards left because mirror is towards left. So in that case, direction which is left from the pole, that will be taken as positive. But in our part, in our syllabus, we always assume the object to be on left side. So if object is on left side, then light rays from the object, they will be always moving towards right. So that means the direction which is right to right with respect to the pole of the mirror, that direction will be the positive one. So that means all the distances which are going to be measured from the pole, the direction which is towards right from the pole, that direction will be positive, and direction towards left from the pole, that direction will be taken as negative direction. So let us suppose this is the pole of mirror. So as we just discussed, the direction, right direction with respect to pole, that direction will be the positive one, and direction towards left with respect to the pole, that direction will be taken as negative direction. And the height of the object or image, that will be measured with respect to the principal axis. So the heights above the principal axis, they are taken to be positive, and the heights which are measured below the principal axis, those heights are taken to be negative only. So that means, because we are assuming the object towards left of the pole, so right side of the pole, that will be taken as positive, and left side of the pole, that will be taken as negative. So this is not new convention for you, because even in Cartesian coordinate system, you take this as plus x-axis, this as minus x-axis, where this is the origin, this is plus y direction, this is minus y direction. So same convention we are following here. The difference is, they do take some origin, here we measure all the distances with respect to pole. So right side of the pole will be positive, left side will be negative, upside positive, downward negative. Okay, so this is the basic. Now, depending upon this convention, let us discuss the sign of different variables in the mirror formula. So first of all, let us talk about the focal length. So focal length is the distance between pole and the focus. Suppose this is the pole, and if this is the focus, or here is the focus, this distance is known as focal length. So in case of convex mirror, the focus lies on right side, as we have seen in the ray diagrams. So if focus is lying on right side, the distance from the pole to the focus, it is lying towards right, so that distance has to be positive. So it means if we are having convex mirror, its focal length will be positive. But if the mirror is concave mirror, in case of concave mirror, focus lies on left of the mirror, left of the pole. So because it is towards left, so this distance will be negative distance, hence focal length will be negative for concave mirror. Okay. Now next is U, means object distance. So because we are assuming that object is being kept towards left of the pole, so that means its distance will always be negative, because object is towards left of the pole. Fine. Now we are having the image distance. So image, as you have seen in the diagrams, image can be formed towards right of the mirror, that means behind the mirror, or it might be formed in front of the mirror. So it depends upon the nature of image. If image formed is real image, it is formed in front of the mirror, that means it is towards left of the pole. In that case, the value of V will be negative. And if image formed is virtual image, so virtual images are formed behind the mirror, that means towards the right of the pole. So in that case, the image distance will be positive according to this convention. If image is on right side, then V will be positive, image distance will be positive. And if image is towards left, this is the case when image formed is real. In that case, image distance will be negative. Okay, so this is the convention of image distance. Now last is convention for magnification. Okay, so magnification has similar type of convention as we are having for image distance, but it is only in case of mirrors. Okay, so now if image formed is real image will be inverted, and as we know, the distances below the principal axis, they are negative. So that is why sign of magnification will also be negative. So if image formed is real, image is inverted, that is why its sign will be negative. If image formed is virtual, so virtual image is generally erect. So if it is erect image, that means it is above the principal axis, so that is why its sign will be positive. So this is the sign convention for magnification. You can see this image distance and magnification, they are having the same convention, because both of them are negative if image formed is real. This is real, this is real, this one is negative, this one is also negative. Okay, so this is the sign convention for these variables. Clear? So the basic convention is the positive direction is that direction in which the light rays are propagating from the object towards the mirror. But as we are assuming the object towards left of the pole, so that means light rays will be moving towards right. So that means the right direction with respect to the pole, that will be the positive one. So according to that, we are having this convention that all the distances towards right, they are positive. All the distances towards left of the pole, they are negative. All the distances above the principal axis positive, below the principal axis negative. And by using this convention, we are having this sign convention for variables in the mirror formula. Okay, that is the significance of magnification. See, this magnification, it has two parts. One part is its sign and one part is its numerical value. Okay, so this sign, it tells us about the nature of image, while this numerical value, it gives us some idea about the relative size of image. It will be clear to you when I will take some examples. So as I said, that sign will tell us about the nature. Now this magnification, it can have two types of signs, means the magnification might be positive or it might be negative. So you remember, if magnification is positive, it indicates that the image formed is virtual image, while if magnification is negative, it indicates that image formed is real. Okay, as we just discussed in case of magnification, that real image means magnification is negative, virtual image means magnification is positive. The same thing I am talking about here. Positive magnification means virtual image, negative magnification means real image. Now this part is important. See, the numerical value, I am denoting it by mod m. Mod, when I place mod, it means I am not considering the sign, I am just talking about the numerical value. So if numerical value is 1, what does it indicate? So as we know, magnification is height of image to height of object. So if it is equal to 1, it means height of image and height of object, they are equal. Okay, so if they are equal, it means the image is having same size as that of object. Okay, and second case is that this numerical value of magnification might be less than 1. So if this magnification is less than 1, what does it mean? So this ratio will be less than 1 if numerator is less than this denominator. It means hi will be less than ho. It means height of image will be less than height of object. So it means magnification less than 1 indicates that the image which is formed, it is diminished in size. Yes. Now next case might be that this magnification is greater than 1. Okay. Magnification is greater than 1. It is possible if numerator is greater than denominator. Yes. So if magnification is greater than 1, it indicates that this height of image is greater than height of object. It means the image which is formed, that is enlarged in size. Okay, so that is the significance of size and sign. Now let us consider some examples. Then picture will be more clear to you. Suppose the magnification produced by a mirror is +2, or magnification is -1, or magnification is +1, or magnification is -1/2, or magnification is +1/2. Okay. So let us decide the nature of image first. So for nature, we are having the convention like if magnification is positive, image formed is virtual. If magnification is negative, image formed is real. So in first case, magnification is positive, so that means image formed is virtual. Now its numerical value is 2. So numerical value 2 means that the magnification or the size of image is twice that of size of object. It means magnification is greater than 1, means image formed is enlarged. In second case, magnification is -1. So minus indicates that image formed is real, because sign is negative, it means image formed is real. But because numerical value is 1, so numerical value 1 means the image is having same size as that of object. In next case, magnification is +1. So again numerical value is 1. It means again the image is having same size, but what is the difference? Difference is in sign. So in this case it was negative, in this case it is positive. So positive sign indicates that image formed is virtual image. Magnification is -half. Minus indicates that image is real, but half. Half means size of image is half of that of size of object. So half means magnification is less than 1, means it is diminished image. So that is the significance of sign and numerical value of magnification.